Welcome to the Compound Grants Workshop for ETHOnline 2023. Compound Grants is excited to be a part of ETHOnline this year. We're excited to see everything that you all build in the hackathon. Let's get started. I'm Adam. I'm the Developer Relations Lead at Compound Labs. I'm here to help out with Ethereum-related development projects that use the Compound protocol. You can find me on Twitter and Discord. I'm mostly in the development channel of the Compound Discord. I can answer your technical questions there. Compound Grants is sponsoring the hackathon this year, and we're really excited to be at this event. We're ready to see all the cool things that you're all building and ready to help out with Compound related projects. And if you want, you can apply to Compound Grants. We can tell you a bit more about that if you're interested and help you get your application accepted. So in this presentation, I'm going to tell you about the hackathon bounties for this year. And if you're not familiar with Compound, I'll tell you about the Compound protocol. I'll tell you about the key differences between the protocols V2 and V3. V3 is the latest version that has new deployments that came out this year and a little bit of last year as well. I'll tell you about protocol governance, and I'll also show you some developer resources so you can get started building right away. All right, Compound Grants has a bounty prize this year of $5,000 USD to the best integration of Compound 3. The rules are that your project must interact with a smart contract or with JSON RPC with any instance of the Compound V3 protocol, or be a supportive project that is specifically created for the Compound community's use. All right, a little bit about Compound. I work at Compound Labs, and we're the authors of the Compound protocol. It's a protocol made up of several smart contracts running on Ethereum mainnet since 2018, and our mission is to create efficient algorithmic money markets. What gets me excited to work in the DeFi space is that we author and continue to steward decentralized, free, and open crypto tools for everyone with an internet connection, including the banked, the underbanked, and the unbanked. And if you think about it, that's a huge amount of market to serve globally. Anyone on Earth with a smartphone and an internet connection can use DeFi and can use Compound. So historically, we've seen interest rates for suppliers to the protocol as high as 15% APY on USDC, as well as other supported assets. And I love that what we're doing is different from TradFi because DeFi systems like the Compound protocol are transparent and they're voluntary with public ledgers where code is law. And with DeFi, you instead get decentralization and transparency, unlike centralized banking and financial systems. That's what gets me excited to work in DeFi and also in the Ethereum space. What is the Compound protocol? Simply put, it is crypto asset money markets, and we refer to it as the Compound protocol. It runs on Ethereum as well as several L2s that you can see here. It's decentralized, which I will explain a bit more shortly. The main use case is that it allows users to earn interest on their cryptocurrencies or permissionlessly borrow other cryptocurrencies. So instead of an asset like Ethereum or USDC sitting idle in your wallet, you can supply it to the Compound protocol and earn a varying interest rate. Users that supply crypto collateral and borrow a different crypto asset against their collateral. And the interest that suppliers earn is driven by the interest that borrowers pay. Those are the two basic uses of the protocol for everyone: earn interest on your crypto or borrow other crypto assets. The protocol can only support crypto assets that are tokenized on Ethereum or other EVM chains as ERC20s. It allows suppliers to earn a variable interest rate on their assets. An individual that uses an app like the ones listed on the Compound homepage or their own code can use every feature of the protocol. Developers can build their own apps that use the protocol as interest-earning infrastructure. Users or organizations can use interfaces to earn interest, to borrow assets, or participate in protocol governance. So use cases that we've seen are crypto wallet applications. They use the protocol to offer interest earning for their users. And also any business that holds funds for a period of time. They use the protocol to earn interest for that period to create some income instead of letting those assets sit idle. So I'm going to give you a little bit of an example here. Let's say you use one of the many interface applications for the protocol. You can supply assets to Compound. When a supplier supplies, they get a fixed amount of C tokens, which you can think about as a 1-to-1 asset that is representing the underlying that you have in the protocol. In V3, C tokens are only minted for the supplying the base asset. They're not minted when you supply collateral. They're 1-1 and they rebase. So when you supply, you have this balance of C tokens in your wallet, and that balance will go up over time automatically. And you can redeem those C tokens for your underlying asset at any time. I'll give more differences between Compound V2 and V3 in a later slide. Those assets are stored in smart contracts that no individual controls. There's an on-chain governance system that will be covered later. C tokens are redeemable at any time. Users can supply for as little as 1 EVM block, and interest accrues every EVM block, which is about 12 seconds nowadays on Ethereum. This enables on-demand supplying and redeeming from the protocol. No need to wait for a lockup period. You can earn interest for supplying to the protocol for even just 1 minute. The other big use case is over-collateralized borrowing of assets. So a user can supply a collateral asset before they borrow. They can only borrow up to a certain amount of USD value of their collateral. So the token value of their collateral is always worth more than their total borrow value relative to USD. So an example would be to supply a collateral like wrapped Bitcoin or wrapped Ether or one of the many others, and borrow a smaller value of DAI or USDC such that your account is over-collateralized. The limit of the borrow depends on the collateral asset. There's a percentage called the collateral factor, which is set for each individual collateral token type. Wrapped Ether and wrapped Bitcoin have different collateral factors. Those factors are chosen by the community members and are selected based on perceived risk of the value fluctuation. In order to borrow, a user must supply a supported collateral asset, and they can then borrow. In V3, there is only one asset that can be borrowed from each instance of Comet. So currently there are deployments of USDC and wrapped Ether as the base asset. So you can supply a collateral and borrow those two assets, or you can earn interest on those two assets, only those two assets. So you can't earn interest on collateral in V3, but you can earn interest on the base asset. If an account becomes under-collateralized, like when the USD value of the collateral goes down or too much borrower interest accrues for that borrowing account, the user's collateral can be liquidated, and a liquidator will perform a liquidation by calling these two methods on the protocol. They can call absorb and then buy collateral. So what happens is the user's collateral is taken over by the protocol, their borrow is repaid by the protocol reserves, and their collateral is sold off at a discount to a liquidator that can then swap it on a DEX for a profit. So supplying only is safer than borrowing. You can't get liquidated if you only supply. There's much less risk involved when a user only supplies and does not borrow. Liquidators keep the protocol safe and collateralized. They are incentivized to do so. So borrowers that become under-collateralized are subject to liquidation of their account at any time. They will lose all of their collateral, but they will get some of the base asset back after the liquidation process ends. Due to the autonomous nature of the protocol, the liquidation system is much harsher than traditional finance. There's no negotiating, there's no delinquent repayments allowed with the on-chain code. So the latest version of Compound is Compound 3. It is more gas efficient and capital efficient than Compound V2. It streamlines the most popular use case of Compound V2, which was to supply a volatile priced asset like wrapped Bitcoin or Ether, and then to borrow a stable price asset like USDC or DAI. This version has additional safety for liquidations. It has a higher threshold for the same collateral factor, so you can borrow more with the same collateral. One asset can earn interest or be borrowed per deployment. That's called the base asset, and it makes opening positions in V3 have less stacked risk than V2. Currently, there are 7 deployments of Compound 3. There are deployments with USDC and WETH as the base asset, and that is on Ethereum mainnet and also on Base. There are deployments on other chains like Polygon and Arbitrum, and there are many more to come soon. This version of the protocol is able to be deployed on any EVM chain. The key differences between V2 and V3 are that V3 has less risk, less gassiness, and can be deployed anywhere that Solidity is supported. V2, you can borrow any supported asset, but V3, you can only borrow the one single base asset per deployment of Comet. Compound V2 and V3 coexist. V2 is not going anywhere. However, there is a deprecation going on by the community at the moment. You can follow along with that at the forums at www.comp.xyz. Basically, what the community is doing is they're lowering the protocol rewards for V2 and also incentivizing users to move from V2 to V3. So here are some key differences between Compound V2 and Compound V3. In Compound V2, C tokens are minted to the suppliers of any asset, and C tokens are about a 50-to-1 ratio. And the C tokens can be redeemed for more underlying as the block height increases. In Compound V3, C tokens are only minted for supplying the base asset, and those tokens are 1-to-1 and they're rebasing, so that balance automatically goes up in your wallet. In Compound V2, you can borrow any asset supported by the protocol, but in Compound V3, you can only borrow the base asset per deployment of Comet, and currently there are only 2 base asset deployments, USDC and Wrapped Ether. Compound V2 was a single system with many assets. It's only running on Ethereum mainnet. And Compound 3 is a single asset focus per deployment, and it's running on several L2s as well as Ethereum mainnet. Compound V2 is a single protocol deployment on Ethereum, and Compound 3 can be deployed on any EVM chain. In Compound V2, max borrowing and liquidation are at the same point. So if you borrow the maximum amount allowed by your collateral, you'll get liquidated in the next block. In Compound 3, there's a separate max borrow and liquidation point. So there's a no new borrows period, which makes it safer for borrowers to borrow the maximum amount, and they won't always be liquidated immediately. In Compound V2, you can earn interest on any supported asset, but in Compound V3, you can only earn interest on one asset per deployment, and that's the base asset. In Compound V2, there are some assets that are not valid collateral. They can't be used as collateral to borrow other assets. And in Compound 3, there is no interest for suppliers of collateral. Collateral is only used as collateral in Compound 3. So in Compound V2, there's an integrated comp distribution into the comptroller contract. In Compound 3, there's an encapsulated rewards contract that can be used with any ERC20 token. It's outside of the protocol and is a little bit neater from a developer's point of view. Compound V2 has one account controller, and that's the one controller of that account. In Compound V3, there's account managers, so you can approve a different manager for your address, or you can revoke those permissions later, and those permissions allow an account to transfer or borrow or withdraw on behalf of that account. Compound protocol is decentralized, and it's governed by the comp token holders. The comp token is a ERC20 token that can be used to propose on-chain protocol upgrades or to vote yes or no on those proposals. And the community can make those proposals. The contracts for governance are in the Compound Finance GitHub organization under the Compound-Protocol repository. You can check them out there. There's a governor contract as well as a comp token contract. So the comp token is the voting and proposing token that allows on-chain governance to function for the Compound protocol. The protocol has been decentralized since June of 2020, and the comp tokens have been distributed to users of the protocol in a slow drip, and those users can take those tokens and vote on proposals, or they can create their own on-chain code proposals to upgrade protocol code or protocol asset configuration settings. And with this token, you can delegate your voting weight to your own address, or you can delegate that voting weight to another address. So say there's a delegate that has more knowledge than you of the protocol. Many addresses can delegate to that one if they trust them to vote on their behalf, or you can always vote on your own behalf if you delegate to your own address. The governance process is a 7-day process for Ethereum, and it's an 8-day process for all L2s. So what happens is a community member will make a proposal, and there's a 2-day review period where all of the other community members can check out that proposal, make sure it does exactly what it says it does, there are no bugs, there are no issues, and also the consequences of that proposal succeeding for apps that depend on the protocol or other protocols that use the Compound protocol as infrastructure. After 2 days of review, there's a voting period where anybody with comp tokens delegated to their address can cast their vote on the proposal, whether they can vote in favor or against the proposal. After the 3-day voting period, the proposal either succeeds or is defeated. It needs to reach quorum of 400,000 votes in order to proceed. After a proposal succeeds, it is in the time lock for 2 days where it is queued and then executed. And after it's executed, there's an additional day and execution for all L2s. So what happens is the time lock will pass the message to the bridge for the L2, and then there'll be an additional 1-day time lock on the L2 before it's executed on the L2. So those are only for proposals that affect the comet deployments on other chains than Ethereum. The time lock phase is only 2 days on Ethereum. So if you're a developer, you can head over to docs.compound.finance to find smart contract method documentation. You can find contract addresses, as well as SDK documentation, explanations for how each of the contracts work, and links to guides and security audits. If you have a technical question or just want to join the community conversation, you can go to compound.finance/discord and join the Discord. If you want to apply for a grant to work on something in the Compound ecosystem, you can go to questbook.app. If you want to see code examples for building on top of Compound, you can go to the Compound-Developers GitHub organization. Or if you want to see the Compound protocol smart contract code, you can head over to the Compound-Finance organization on GitHub. Here's the workshop we're going to be working on today. You can head over to GitHub and check out this repository. You can always clone it. It's open source. And you can use this QR code with your phone if you want to check it out on your phone. Compound Grants is an independently led organization that funds projects that are working on the protocol. You can head over to questbook.app if you want to apply for that program. They have rolling applications, and they have funded many builders in the ecosystem and got them going, building on Compound. If you have more questions about that, you can come over to us during the hackathon and ask us, and we're happy to help and connect you with the right people to get your project approved for a grant. If you're not sure what you want to build in this hackathon, we have an ideas blog post. You can head over to this link if you want to check out that ideas post. We have several ideas that can help you win this year's hackathon bounty for ETHGlobal New York. And you can also see links to previous year's winners of hackathon prizes in the ETHGlobal hackathons. So please check out this blog post. Next, I'm going to walk through a developer workshop and show you how to build a dApp that you can use to interact with Compound 3 on Ethereum mainnet as well as Base. Here we have a repository for the code in this workshop. You can clone this code and use it for your own project in the ETHOnline hackathon. Here we have code for a dApp that has a server which hosts a Ethereum provider that hooks up to JSON RPC through Alchemy, and it connects to mainnet or Base. So you can use a forked version of mainnet or Base to interact with the Compound protocol via this user interface. And I'm going to show you how to select the right network. You can get JSON RPC provider URLs from alchemy.com for free. And when you run the server application locally, it will fork the network that you choose, and you pass your JSON RPC URL as a environment variable to the start command for the npm server. It is a JavaScript, Node.js Express server. And first you have to install Node.js if you don't have that already. And I'm going to clone this to my machine, and I'm going to walk through the code and show you how to use it. So I have a command here to clone to my machine. I'm going to go to my terminal. I'm going to paste in this command. Then I'm going to change my directory. And then I'm going to use the npm install command, which will install all the dependencies. So I'm going to cat my package.json file. So you can see that there are 3 dependencies in this project. They are ethers.js, express.js, and hardhat. I'll walk through how those are used. I'm going to open this in a text editor. I like Sublime. The first file I'm going to look at is a server script. So this runs on my local machine. You run this using the npm start command. I have all of the relevant contract addresses in this file here called addresses.js. So this references the Compoud protocol. Open this file here. We reference each of the assets that are supported by each of networks that Compound 3 is on. So in this workshop, we're supporting mainnet and base. So the assets that you can use Compound 3 with on those networks are listed here. As part of the server script, we're going to fork the live blockchain to a local version we have here where we can control more factors like the gas costs, and we can send ourselves tokens for free. So we can do everything that we need to do for testing purposes. So I'm going to show you where I got all of these addresses. If you head over to docs.compound.finance, you'll find the Compound protocol documentation, and there's explanations for every concept of the Compound 3 protocol, as well as method documentation for the smart contracts. And we have addresses for the relevant smart contracts here, including each of the assets that are supported by the deployments. Of course, you can switch the Comet deployment by clicking on the tabs here, and the addresses down here will change, and you can find the ones you need. So in this workshop, we're working with mainnet, USDC, and WETH, and also base USDBC and base WETH as well. So you can use the copy button to copy these contract addresses, and you can paste them into your files here. So we have 4 parameters for each of these asset objects. And this is used in our server file. Down here, we have a seed local dev account. We have our test account that's going to be running on our local machine with 10,000 base token. Well, on mainnet, it's Ether, and also on base, it's Ether. So we get 10,000 Ether to test out things with on our local machine. And we can also seed our local dev account with ERC20 tokens in addition to the gas token. So we do that using this function I wrote here. It uses the hardhat impersonate account, and it basically moves some tokens from a whale to our test wallet address so that we can use them in our dApp user interface. So each of the assets you see here, we have the asset address itself, the whale. In this case for WETH, there's some WETH sitting in the contract itself that was accidentally sent there. So we can take some of that and send it to our localhost account. So this is the first address of my development mnemonic. And my development mnemonic is listed in my hardhat config file. So definitely do not use this on any network besides localhost or the test network. You don't want to use these on mainnet. There are malicious actors that will honeypot and steal tokens. So definitely do not use this mnemonic on a live network, only in your development node, it's fine. So the first address of that mnemonic is here, and this address will have 10,000 gas tokens, and also, thanks to our server script, will send us a bunch of ERC20 tokens. So in this addresses file, I also specified the amount. So for wrap Bitcoin here, we're going to send ourselves 5 wrap Bitcoin, 5,000 USDC, etc. And you can change these however you'd like and find whales on Etherscan or Block Explorer that you want to take some assets from for your testing purposes on your local machine. So we run this server script. We have our provider URL from Alchemy as a environment variable, and the script will use that to boot up JSON RPC server on your machine. We specify the network we want to use as an environment variable. We want to run our DApp and test against mainnet. We could pass mainnet as a parameter, or we can pass base as a parameter. The server will, the script will start up an Express server and serve the files we have in the public folder here. We have some HTML, CSS, and JavaScript that I'll go through in a few minutes. And we're going to listen on port 3008. So you can visit this address in your web browser and see the user interface. We create a JSON RPC server using hardhat. And it's going to use the configuration that's set in our hardhat.config.js file. And we're going to have either a mainnet fork or a base fork. So I actually delete that. And we're going to seed our first address in our mnemonic with the ERC20 tokens. So this loop here goes through each of the assets for the network that we selected. So we got mainnet and base in our addresses file. So based on whichever one we choose, we seed each of those assets to our first address. And then once that's done, we'll see ready. So I'm going to run this script. I'm going to run it against mainnet. We're going to do that by doing npm start mainnet. And I already have my environment variables for my JSON RPC API URL as listed variables in my configuration for my terminal, so I don't have to write them out here like you see in the GitHub README. So I'm going to run this command, and we're going to see that our interest rate DApp is served at localhost 3008. We have our Ethereum node fork running 8545, and we seeded our development mnemonic account with wrapped Ether, wrapped Bitcoin, and USDC. These are assets that we can use with the mainnet instances of Compound 3. So now that we're ready, we can play with this app. Okay, here's what our app looks like in the browser. We have the two deployments of Compound 3 on Ethereum mainnet. We've got CUSDC v3 as well as CWETH v3. We can select them here in the select box. We can supply or borrow the base asset. And when we select an instance of Compound 3, we can see the supply APR and the borrow APR. So currently for CUSDC v3 on mainnet, we have a 2.98 supply APR, and we have a 3.92 borrow APR. We can supply collateral down here if we want to borrow, so you need to supply collateral before you borrow. So we can choose an asset to supply here, and we can also withdraw it. And then down here it displays the balances. We haven't interacted with Compound 3 yet, so our balance for every asset is 0. And of course, if we take a look at our MetaMask, we have 10,000 Ether. That is test Ether on our localhost account. We have 5 wrapped Bitcoin and 5 wrapped Ether, as well as 5,000 USDC. Thanks to our server script that seeded our accounts. So these are all test assets available on localhost only. So you can play with your forked blockchain here in test mode. When we switch the Comet deployment using the select box, we have a different APR listed. So this is for the CWETH v3 deployment on Ethereum mainnet. Have a 1.86 supply APR, and the collaterals that we can supply are Coinbase Ether as well as wrapped staked Ether. So these are the mainnet deployments of Comet. I'm going to show you how to set up your app so you can play with the base deployments next. But before I do that, I'm going to show you the front-end application code. So here we have our HTML. We have an Ethereum enable button in case you have not enabled MetaMask to work on this web page. You can click on this button and MetaMask will pop up requesting your permission to allow the page to use your wallet. We have our select box here, which gets filled with the instances of Compound 3. we have those listed in our constants.js file. So this is a JavaScript file with just some references. We have each of the asset addresses of the Compound 3 instance. We have the address of comment. We have the name that shows up in the select box, as well as the value we can reference in our JavaScript code later. The chain ID, so we can differentiate between base and mainnet. We also show asset address, symbol, and decimals, so we can do math to supply and borrow the right amounts later. So we fill in our instance select box, which we can see here. I've already enabled Ethereum on the page, so we don't see this button hidden. And in our 3 little modals we have on the page, we have a way to show the supply APR and the borrow APR, as well as a button and a text box for entering an amount to supply or withdraw. And then down here, you can also supply or withdraw collateral. Then we have our little asset interface that displays our balances within the Comet protocol. So we haven't done anything yet. Each of those balances are 0. So at the bottom here, we have a reference to Ethers.js. We have version 5 that we get from a content delivery network. We have our constants.js file, which has all of the references to the elements in HTML, as well as our ABIs and some JSON objects with the Compound 3 instance information. And then the important file is app.js. That's where all of the logic happens for the functioning of this dApp. Let's take a look at that. Here's our app.js file. We have an event that fires only after the web page has finished loading. That's when each of these functions run. We have a selected account, which is the first account in our MetaMask that we're using to interact with the page. We don't have a window.ethereum object. There will be an alert to the user saying install MetaMask to proceed using the page. You can't use the dApp if you don't have a Web3 wallet. We're going to make a request to the Ethereum object to get the accounts. And once we're connected, we're going to fire this event here. And if we click the Enable Ethereum button, which you'll see on the page if you're disconnected, it'll also fire that event. So first thing we do is get the chain ID so we can differentiate between mainnet on Ethereum and also base. They have different chain IDs. We're going to get the first instance with the matching chain ID from our constants file. So if we're connected to Ethereum mainnet, we're going to see USDC v3. And if we're connecting to base, we're going to see CUSDBC v3 as the first instance in our select box. So we go through each of the common instances and set up our options we have in our select box. We select our account thanks to MetaMask and Ethers.js. We allow our instance select box to be seen on the page. It's hidden at first. And the Ethereum enable button is hidden if we're connected with our MetaMask wallet. We set up an event handler for our instance select box. So every time it changes, it's going to re-render the user interface with the newly selected common instance, so you can see a different APR, and you also see different collaterals available to supply and borrow from the protocol. Of course, you're not able to borrow collateral. That's a key difference between Compound v2 and v3. So those are just collaterals that you can supply and withdraw. We have our render UI function here. This basically sets up all of those elements on the page we saw. We refer to our instance of Comet by index that we have in our constants.js. So there's 4 available that we can use in this dApp at the moment. We assume that the first one listed in the array is the base asset. So that's either USDC or wrapped Ether. Each of the collaterals are all of the other assets in that array. we set up our collateral select box by adding option elements to that select box HTML element. And we add one for each of the collaterals so we can select it and supply it using the little modal here. So we could select a collateral and then put in a number here and supply. We get the APRs of the instance of Comet that we're referring to. We use this function. It uses ethers.js to create a contract for Comet. We have some of the Comet methods referenced. We have our ABI here for getting all of that data from the Comet contract. We're going to get the utilization, supply rate, and the borrow rate. We're going to do some math to show a human readable percentage. And we're going to return an array with the supply and borrow APR. And we're going to set those numbers in our HTML elements here. We're going to chop off any excess decimals because sometimes JavaScript math will leave us with a lot of decimals. So to make it nice and neat for the user, we'll do the toFix method. And then we're going to set up event handlers for each of our buttons. So when we click the base asset supply button, we're going to supply. We're going to specify the number that the user put in the text box. We do that for withdrawing, as well as collaterals, withdrawing, and supplying. Let's take a look at those supply and withdraw functions. So again, we're setting up a Ethers contract. We're getting the signer for MetaMask. We're finding out the specific data about the asset, which we have listed in here. We need to know the symbol, the decimals, and the address. We set up a contract for the specific ERC20 asset. We use the ERC20 approve method to allow Comet to move it from the end address to the Comet contract. We have the receipt. We can use that. We can log it later so we can debug if there's an issue. And this transaction here supplies to Comet. And we log the error in case there's an error. Withdraw method is pretty similar. Doesn't have a ERC20 transfer because it doesn't need it. With withdraw, we can send the asset right to the end user address when they're ready to withdraw. All right. So the last thing we do when we render the UI is we draw the balances. So this is only for once a user has begun using Comet. They will see different numbers here in the Comet balances area of the dApp. So we use our getBalances function. We're going to make a contract for Comet. And we're going to go through each of the assets that are available to use with Comet. And we're going to use the user basic as well as the collateral balance of functions for our account that we have selected in MetaMask. We're going to get the balance and we're going to take all of those requests, wait for all of them to finish using promise.all. And we're going to have an array of balances. And we're going to add them to our results and return it to our render UI function. Or sorry, our draw balances function, which is here. And then after we've gotten all the balances, we can insert them into our HTML here in a label. And it'll show the balance as well as the symbol of the asset. So like we see here, we have wrapped ether and 0. The user has not yet used the protocol. So that's how each of the balances is written to the page. And that is all of the JavaScript in app.js. Now let's try and use our app. So the first thing I'm actually going to do is I'm not going to use it with Ethereum mainnet. I'm going to try and use it with Base. So in order to do that, I'm going to kill my server script. And instead of using npm start mainnet, I'm going to change it to npm start base, like that. And you'll notice that the logs are a little bit different from earlier. We're going to seed our account with USDBC, CBETH, Comp, and Wrapped Ether. So these are the assets that can be used with the base deployments of Compoud 3. So we have the same application running at the same address, except when I refresh this page, it's going to show me the base instances. Okay, it's not going to show them to me just yet because my MetaMask is not set up for the localhost server. So what I'm going to do is I'm going to go to MetaMask, and I'm going to open my settings. I'm going to go to General. And I'm going to go to, no, General is not the right place. I'm going to go to Networks. And I'm going to go down to localhost 8545. And that's going to open a new MetaMask page for me. I have the localhost 8545 network selected, and it's going to try and get the chain ID. And obviously there's an issue because chain ID 1 is for Ethereum mainnet. Base uses a different chain ID. So if we go over to our server file, oh no, not our server, we want to go to hardhatconfig.js. We can see that mainnet uses a chain ID of 1 and base uses 8453. So I'm going to copy that value. This is the localhost node configuration that we set up. We have the chain ID based on the network we're connecting to. We have our dev mnemonic here, which is what I have in my MetaMask for interacting. So yeah, I'm going to take this chain ID. I'm going to paste over with the base one because that's the network we're forking now with our hard hat node that we're running locally. I'm going to save that, and it's saved successfully because it's connecting to my localhost node I have running right now. Okay, so when I go back to my dApp, when I refresh the page, this will now say base. Great. So we have CUSDBC v3 base. The current supply APR for that version of USDC is 1.78%. And the available collaterals we have are Wrapped Ether and Coinbase Ether. So if I go over to my MetaMask, you can see I have 10,000 Ethereum, I have 100 Wrapped Ether, I have 5,000 USDBC, and 5 Coinbase ETH. And the place that I define this is in my addresses file, which is server side. My server references the addresses up here at the top. Go over to addresses, and we have base. So we're going to seed our localhost account with each of these 4 assets. So 5,000 USDBC, we have 5 CBETH, and 100 Wrapped Ether. So that's what we see in our MetaMask wallet over here. And if I want to supply the base asset, which is USDBC, I'm going to try and supply 100. When I click this button, MetaMask is going to pop up and ask me for approval. Okay, I got a nonce issue with my MetaMask because I did not reset it. So this is a simple fix. You go into MetaMask, settings, advanced, and you click click clear activity tab data. This will clear my nonce data so MetaMask does not get confused when it tries to submit a transaction to my localhost blockchain. So I'm going to try again. I'm going to try and supply. Going to try and supply 100 USDBC. Well, it's going to approve it first. And once the approval transaction mines, which takes just a second on my localhost hard hat node fork, and then we can do the actual supply method. So we're going to supply, and it's going to cost us this very small amount of Ether in gas. Going to confirm. And then you can see down here that my USDBC balance within the Compound protocol is now a positive number, 99.99999. And here we have our transaction receipt that we logged to the console. We did this within app.js. Here we have our receipt that we logged to the console. Can check out the events that fire. Our token transfers as well as supply events within Comet. And next, I'm going to try and borrow. So in order to borrow, I need to supply collateral. I have 100 wrapped ethers, so I'm going to supply 10 of them to the protocol. Okay, once they're supplied, we can see that my balance is updated. Since I interacted with Comet, it actually recalculated the amount of USDBC owed to me, which is now more than 100 because interest accrued in the time that it took me to supply my collateral. So now that I have collateral supplied, I can actually borrow USDBC. And I'm going to try and borrow a number that's greater than I have already supplied. So I'm going to try and borrow 300. So I should have a USDBC balance of like negative 200 once I withdraw. So actually, this is the wrong text box. I'm going to put it here. I'm going to put 300. I'm going to withdraw. And MetaMask is going to give me one transaction that I can do. And yep, now that it has mined, it mined instantly. Here's the receipt. We can see that I have a negative balance of USDBC, and it's slightly less than, or actually more than, 200, negative 200 USDBC. So this is a little app you can use to supply collateral or supply the base asset or borrow the base asset and play around with Compound 3. You can set it up for base. You could use either of the deployments on base or mainnet. Remember, you need to change the chain ID within your MetaMask localhost settings like I did here. And you can choose the instance, or you could choose the network that you're using by choosing a parameter here for your npm start command. You can use base or mainnet. And you can check out those configurations in the server.js file as well as the hard hat config. You can build on top of this. You can add more deployments of Compound 3, which we have in the documentation. You can check out each of those addresses here, and you can change this app to whichever addresses you need for whichever networks you're working on. Each of the protocol contracts for Compound 3 have explanations listed here in the documentation. And there's also more developer resources available, including some code examples in the Compound 3 developer FAQ. This is a GitHub repository with a bunch of tests as well as Solidity code for interacting with Compound 3 a little bit more deeply than I did in this demo. We have examples for running proposals and upgrades to Compound using scenarios, migrations, and workflows. There's a guide here if you want to look at that. You can create your own liquidator for insolvent positions on Compound 3. You can liquidate them, or underwater positions. You can liquidate underwater positions using this guide. You can also build a common extension that goes in the app.compound.finance extensions page. You can have external apps there. And this page also has a search box at the top. You can search for any methods or relevant topics for comment here. And you can go to those explanations and read about them. Remember, if you want to apply for a grant, you can go to questbook.app and you can build on Compound and get paid to do it using the Questbook program. So again, that's at questbook.app. You can find us in Discord, and we'll explain how to apply for a grant here, or you can head over to this page and try it out for yourself. Apply for a grant to build on Compound. And of course, if you want to get involved with the Compound community, you can always go to comp.xyz, which is the forums. So here's where the discussion happens for Compound protocol development and upgrades. Community talks about what they're going to do next with the product roadmap of the protocol. We also discuss development, grants, new markets, governance process, and we talked about times of developer calls in Discord. So everyone is welcome to attend there or state your opinions here or create new topics here and join the discussion at www.comp.xyz. I hope this workshop was helpful to get you started working on your hackathon project. Remember, there's a $5,000 USD bounty for the best project building on Compound 3 or for the benefit of the Compound community. On behalf of Compound Grants, thank you for coming to the hackathon this year. Thank you for watching my presentation. Best of luck to the hackers in the hackathon. Excited to see what you build. Remember, you can always message us in Discord. We're happy to help you out with technical questions or explaining how concepts work in Compound 3. And we're also happy to review your project and let you know if it's eligible for the bounty. Thanks again for watching and hope to hear from you soon. And best of luck to the hackers in the ETHOnline 2023 hackathon.